Across the endless universe, we are silent observers. Every night, we look up and read stories written in light. Stories of stars being born, shining for millions of years, and eventually fading away. Yet, among this endless sea of light, there are places where no story can be seen at all. There exist regions wrapped in a darkness so complete that even light, the fastest thing in the universe, can never escape. This is the realm of one of the most mysterious and powerful objects ever discovered: the black hole. Despite its name, a black hole isn't really a hole. It is a place where gravity has become so overwhelming that space and time themselves bend inward. It is what remains when a massive star reaches the end of its life. When the star is gone, it leaves behind a pull, so powerful that nothing known to physics can escape it. For decades, we've only been able to observe these giants from a safe distance. But have you ever wondered what would actually happen if you crossed that final boundary and fell into one? To answer that question, we have to begin long before the black hole itself exists. Every black hole begins with a star, but not just an ordinary star like our sun, and star much more massive. For millions of years, it survives by balancing two unstoppable forces. One, gravity, which constantly tries to crush it inward, while second is nuclear fusion, which pushes outward with unimaginable energy. As long as those forces remain in balance, the star lives. But every star has a limited supply of fuel, and eventually it runs out. In a matter of seconds, gravity wins. The core collapses under its own incredible weight while the outer layers explode outward in one of the most violent events the universe has ever witnessed, a supernova. For a brief moment, that dying star can outshine an entire galaxy. But the real story isn't the explosion. It's what survives it. The collapsed core continues falling inward. Smaller, denser, more compressed than anything we can recreate on Earth, gravity becomes stronger and stronger until it reaches a point where escaping would require traveling faster than light itself. And because nothing can move faster than light, nothing ever escapes again. And a black hole is born. From a distance, it doesn't look like the monster we've imagined. It looks almost peaceful. A perfect sphere of darkness, surrounded by a brilliant ring of glowing gas spiraling endlessly around it before vanishing forever. Beautiful, silent, almost inviting, but appearances can be deceiving. The closer we drift, the stronger its pull becomes. Not a sudden tug, but a gentle invitation that grows stronger with every passing second. Ahead lies an invisible boundary. Scientists call it the event horizon. Imagine drifting toward the edge of a waterfall. Far away, the current is weak. You can still turn around, but there comes a point where the water is moving faster than you ever could. Cross that point, and every direction leads to the same destination. The event horizon is that point. There are no warning signs, no bright flash, no invisible wall. You simply cross a line beyond which the universe no longer offers a way back. Something remarkable happens next. If someone were watching from a safe distance, they would see your journey slow down. Your movements would become slower and slower until you seemed frozen at the edge of the black hole. Your light would gradually fade, becoming redder and dimmer until you simply disappeared from view. To them, you never truly fall in. But from your perspective, nothing unusual happens. Your heartbeat feels normal. Your watch continues to tick. You cross the event horizon without even realizing you've done it. Both realities are correct. That is the strange beauty of Einstein's universe. But then, the black hole finally reveals its true nature. Gravity is no longer pulling equally on your body. Your feet, being slightly closer to the black hole than your head, are pulled just a little harder. At first, the difference is tiny, then it grows. Your body begins to stretch. Bones, muscles, cells, eventually even atoms themselves can no longer remain together. Physicists gave this terrifying process an oddly harmless name: spaghettification. If the black hole is relatively small, this stretching would destroy you long before reaching its center. If it's a supermassive black hole, you might drift peacefully beyond the event horizon before gravity finally becomes overwhelming. Either way, there is no return. Before everything ends, you look back one last time. The universe no longer resembles the one you left behind. Stars bend into impossible shapes. Galaxies wrap themselves around the darkness. The entire sky appears twisted by gravity itself for one final moment. Everything you've ever known, every star, every planet, every person who has ever lived seems compressed into a shrinking circle of light. Then it disappears. Your journey ends at a place our mathematics calls the singularity, or perhaps something else entirely. This is where our understanding of the universe reaches its limit. Einstein's theory of gravity predicts one outcome. Quantum physics predicts another. Both describe nature with astonishing accuracy, yet here they refuse to agree. What truly lies beyond this point? A singularity, a bridge to another universe. Something we haven't imagined yet, or is the question itself incomplete? The truth is, we don't know, and perhaps that is the most beautiful part of all. Black holes remind us that the universe is under no obligation to reveal all of its secrets. Every discovery answers one question only to uncover another. No matter how far science takes us, there will always be another horizon waiting beyond the last. Perhaps that is why we continue exploring, not because we expect the universe to become less mysterious, but because every mystery brings us one step closer to understanding our place within it. And maybe that endless search for answers is what makes us human.